In our next example, we have to find the multipliers before we can write an equation. So we're going to practice just that first. So as I was talking about when we looked at the vocab, for example, if we have a growth rate, what that means is, let's say the population of Cottage Grove was growing at a rate of 5%. What that means is 100% of the people we have, we keep, and we're adding on an additional 5%. So there's two ways to think about this. Probably the easier way is to take 100% of the people that we're keeping, add on our growth rate to get the percent that it's growing at, sort of, and then turn it into a decimal. When you put it into your exponential equation, you can't put a percent in. You have to have it converted to a decimal before you can put it in as a percent. The vocab actually had it as convert your percent to a decimal first, and then add it to 1. So you can think about it either way. Some of you might have an easier time thinking about adding your percentages together first. So the second is a rate of decay. So this would be commonly used in medicine. So for example, a doctor prescribes a medicine and they want to know how long it's in your bloodstream. So that tells them how often you can safely take the medicine and not have too much in your bloodstream at one time. So we've got a rate of decay. What that means is 6.5% of, let's say, the medicine is leaving your body or being metabolized out of your system. So to get the amount that we're keeping, because that's what we use in our formulas, how much do we keep in our bloodstream? You could think about it as 100 minus the 6.5%. That would mean that you are keeping 93.5% of the medicine in your system. But once you put that into the equation, again, convert it to a decimal. So we've got a couple of word problems here. Our first one is exactly what I was just talking about. This time we're looking at caffeine. So you drink a cup of coffee, how long is that caffeine in your system? Or how much is still in your system after an hour? We're losing 25% of the caffeine per hour. So the first thing we have to do, this is a rate of decay because the amount of caffeine is decreasing. So to get our multiplier, we would do 100 minus 25%. We're keeping 75%. In this case, because we weren't told how much caffeine, we're just looking at it as a percentage. That A value, where the initial is 100%, converted to a decimal is just 1. So our A value is 1. The base of the exponential is the growth or decay rate, in this case the 75%, and then the exponent after t hours. You could also use x. Typically for exponential functions, you'll see t as the exponent quite a bit because we're usually talking about time. So what percent will be left after 2 hours? Substitute 2 for t. And that rate is about 56, actually this one's exactly 56.25% of the caffeine would be left after 2 hours. Similar question, how much will be left after 6 hours? Substitute 6 for our time. And this one, there's only about 17.8% left after 6 hours. Next question, we're looking at an investment. So this is that it seems complicated, but it actually isn't too bad to memorize. So we'll go through what all of these pieces mean now that we have some numbers to substitute in there. So what is an investment of $2,000 worth? So the investment is your P, that's your principal or your initial amount. 1 is, again, this is growing, our money is growing. So the 1 is, for the same reason how we found the multiplier before, we're keeping 100% of our money, and I just realized I put 200, we'll make that 2,000. So we're keeping 100% of our money, that's what that 1 is for. The R divided by N. So in this case, our interest is compounded semi-annually. Semi means twice. So N is the number of times per year that our interest is compounded. So what they do is they take that interest rate and they divide it by 2 so that they're giving you half, oh, I don't know where that came from. They're giving you half your interest after 6 months, and you'll get the other half of your interest at the end of the year. Just as a side note, when you're looking to invest your money, the more often they compound it, the more money you earn, because after the first 6 months, you're only earning interest on that $2,000. But at the end of the year, you're now earning interest on your interest. So the more often they pay you your interest, the more money you make. All right, and then we raise it to the NT power 2. Oh, my calibration just jumped way off. Times 7, that should be our exponent. 2 times 7. And now all of a sudden it's working again, sort of. So what that means is that it's compounded twice a year for 7 years. So it will be compounded a total of 14 times. So that's our exponent. Punch all of this into your calculator, multiply the 2 by 7 in your head, and make sure you have an exponent of 14. If the numbers get really big, either multiply those two together so that you know what your exponent is, or use parentheses around them when you punch it into your calculator. This is about $3,348.60 is what our account would be worth after 7 years. And you try. For some reason I have B twice. We'll just change this one to C.